acids, bases and salts. When we eat food, then you see the taste is sometime it's bitter, sometime it's sweet, sometime it's sour, and these taste is because of the presence of acids and bases in them. So what are acids? These acids are defined as one which produces hydrogen ions in water. For example, the sulfuric acid, the hydrochloric acid, and they will give you a sour taste, and they will turn the blue litmus to red, and this is the confirmation test for the presence of acid. When acid they react with metals, gases are involved or gases are evolved. They liberate gases. So when the acid react with metal, it will give you salt and hydrogen gas. For example, magnesium combined with sulfuric acid will give you hydrogen and magnesium sulfate. So this is a salt and this is hydrogen gas. This is liberated. The reaction of acid with carbonates and bicarbonates, the bicarbonates and carbonates, so carbonate, sodium carbonate, when it reacts with say HCl, hydrochloric acid, it will form sodium chloride and water and carbon dioxide. When acid combines with bicarbonate, say this is acid, it combines with NaHCO3, it will give you sodium chloride, again water and carbon dioxide. So what are the similarities between these acids and bases? First of all, they both react with water and they produce ions in water. One hydrogen, the other hydroxide ion. Both acids and bases, they will act as electrolyte. That means they will liberate the ions. That is why they are good conductors of electricity. And both of them, they change the color of the litmus paper, blue to red, red to blue. We can classify acids like the organic acids or mineral acids. Those acids which are derived from plants and animals, they are known as organic acids. For example, citric acid from food, and you might have eaten the citric acid fruit like the oranges, lemon, etc. The mineral acids, they are inorganic acids like sulfuric acids. And acids can also be classified as strong acids and weak acids. Strong acids are those acids, they are completely dissociated into ions when they are poured or mixed with aqueous solution. For example, the sulfuric acid, hydrochloric acid, see this is HCl, hydrochloric acid. When it is in aqueous solution, it completely dissociates or disintegrates. While the weak acid, those are called weak acids who do not dissociate or disintegrate completely into ions in aqueous solution. For example, this acetic acid, it doesn't completely disassociate. So acid can be dilute acids and concentrated acids. If we have low concentration of acid in an aqueous solution, we call them as dilute acids. While if we have high concentration or more concentration of that acid in aqueous solution, we call it as concentrated acid. Okay. The acid, generally the strong acids, when they are mixed with water, we have to be very cautious because it releases a lot of heat and this is generally harmful. So acid can also be classified on the number of hydrogen ions like the monoprotic acids and diprotic acids. The monoprotic acid are those which gives 1 mole of hydrogen ions per mole of acid, while diprotic acid are one which produces 2 moles of hydrogen ions per mole of acids like the sulfuric acid. Bases are those which produces hydroxide ions in aqueous solution. And these bases, which are water soluble, these bases are termed as alkalis. Alkalis are water soluble bases, and they turn the red litmus to blue bases. They have a bitter taste as against the acids which have sour taste. And bases, they also produce this carbon dioxide when they react with carbonates. And they also evolve hydrogen gas, means when bases react with metal, hydrogen gas is liberated. So when the metals react with bases, that is, see here, that this is sodium hydroxide. When this is a base, and when it combines with zinc, it gives you this component and hydrogen is released. So bases react with metals, this is a metal, and produces hydrogen gas. When they react with acid, like this potassium hydroxide combines with this acid, this is hydrochloric acid, then they form salt, this is potassium chloride. When they react with non-metallic oxide like this one, then the sodium hydroxide is going to give you sodium, this carbonate and water. So base react with non-metallic oxide to produce salt and water. Bases can be classified as strong base and weak base. And strong bases are those which completely dissociate or disintegrate into ions when they are mixed with aqueous solution, for example sodium hydroxide. And weak base are those which does not dissociate completely, means do not disintegrate completely into ions when they are mixed with aqueous solution, for instance the ammonium hydroxide like NH4OH. So bases are also classified as dilute base and concentrated base. This simply means the solution which have low concentration of base in aqueous solution is defined as dilute base, while those which have high concentration of base in aqueous solution is known as concentrated base. What are strength of acids or base solution? This is there is a number which is known as the dissociation constant Ka, and the dissociation constant of weak acid and weak base. It can be represented when we take the formula of how these react, and there are certain ions, and these ions, when for example if you take this example, then we have this A minus, that is ion, H3O and HA is combined. This HA may be say a weak acid, and then the dissociation constant is represented with this expression or this equation by this H3O plus, this one and this one on the right hand side, divided by this HA. So this is the dissociation constant. pH, P small, H capital. What is this pH? The acids and bases, they are determined by using this pH scale. The strength of these acids and bases are determined using pH scale. So it is a scale in order to measure the hydrogen ion concentration in a solution. This P in this pH stands for potens. It's a German word which means power. This means power. So there is a scale. This is say 0 from 0 to 14. So the pH, when it is equal to 7, means this number, then the solution is neutral. When the pH is greater than 7, that means we are going for alkaline or bases. When it is lower than 7, then we are going for acidic. So if it is 0, it's highly acidic. If it is 14, it is highly basic or alkaline. Why this pH is so important? The human body works at pH around 7.4. The stomach of our body, the pH is 2. It has hydrochloric acid in it, means our stomach has hydrochloric acid. It also it is needed for the activation of pepsin protein, which is required for the digestion of protein. When we are eating food that contains sugar, the bacteria which is present in our mouth, it breaks the sugar to form acids, and this acid, this lowers the pH in our mouth. And you see that tooth decay, if you have pH of acid which is formed in the mouth which falls below 5.5, then the tooth decay can be there. Why this is happening? Because the acid becomes strong enough to attack our enamel of the teeth, and it may corrode it. So this sets, or this result in tooth decay. So you need to say do cleaning of your mouth after eating food. That is the best idea. And various animals and plants, they also protect the enemies by injecting painful and irritating acids and base into their skin. When honeybee stings a person, it injects the acidic liquid into skin. When wasp stings, it ejects an alkaline liquid into the skin. So what is the remedy? You can, if this is acidic, you can put the base in order to neutralize. If it is alkaline, you can put the acid to neutralize. So in this first case, you can rub with mild base like baking soda solution, or this will give you some relief. In the second case, you can rub it with mild acid like vinegar. The soil pH and plant growth is also very important, because most of the plant grow best when pH of soil is very close to 7. If soil is too acidic or soil is too basic, the plant would not grow, or they would grow badly. The soil pH is also affected by the use of chemical fertilizers, and we need to adjust the pH in order to have good growth. So if soil is too acidic, it can be treated with quicklime or slag lime. If the solid is too alkaline, the alkalinity can be reduced by adding manure or compost. So it is actually decaying organic matter you can put. Salts. When the acids and bases they combine, they neutralize, and when they neutralize, they form salt. So strong acid and strong bases, they combine to form neutral salt. For example, this sodium hydroxide mixed with the hydrogen HCl, that is hydrochloric acid, it forms sodium chloride and water, and this is a neutral salt. And strong acid and weak base, they combine to form acidic salt because the acid is strong. Weak acid and strong base, they combine to form basic salt because here this base is strong. For example, in the first case, hydrochloric acid will then combine with ammonium hydroxide will give you ammonium chloride. And then in the second one, the acetic acid combines with the sodium hydroxide in order to form sodium acetate. Okay. There are other examples also, but we need to know one thing, that the most common salt or the basic ingredient of our food is table salt, which is sodium chloride, which you see here, sodium chloride. What are indicators? They are the substances that will indicate the acidic or basic nature of solution using color change. For example, the litmus solution, the methyl orange, the phenolphthalein, the methyl red, these are all the indicators. The acid would convert the blue litmus to red. The base will convert the red to blue. Bases convert this. And the phenolphthalein will remain colorless if acid is being poured or if there is a presence of acid, but it will turn pink if there is a presence of bases. There are certain important compounds and their uses, like the common salt, the sodium hydroxide. This is also known as sodium chloride or NaCl, obtained from seawater, and they are also found on rocks which are known as a rock, like rock salt. This NaCl is used to produce or make baking soda and washing soda, and the common salt is added to these pickles to prevent bacteria formation. About sodium hydroxide, it represents NaOH, or represented by NaOH, and when the electricity is passed through the aqueous solution of sodium chloride, this sodium hydroxide is produced. And this is very important because it is used for water treatment and metal processing.